Graphing is one of the most important skills that you can use um, as a scientist. So what we're going to do is talk about how we use graphs and construct graphs to represent and help us interpret and analyze our data. Now, the whole purpose of graphing is to make things just easier to see. For instance, if we take a look at the data we have plotted here, we have a data table and a graph. The data table is a bunch of numbers, but the graph, you can visually immediately see the trends in the data. Our blue line there kind of dips and eventually increases, whereas our red line increases greatly, drops, increases again, and drops again. So you get to see patterns and changes in the data much easier. You can also estimate points in between. So by looking at the numbers, you do understand that there's numbers in between those, but you don't know exactly what those numbers might be. Whereas if we're using the graph, you can simply locate one value and then go up to the point in the graph where it intersects and find the next value from that. And it gives you a very definite value in between those 2 points that you're looking for. Now, the first thing that you need to do when you're going to graph something is be able to interpret your data. What are you actually graphing? To do this, we determine which variable is going to be our independent and dependent variables. The independent variable is going to be standalone. It doesn't change because of any other variables. The experimenter is one that changes that. Typically, if we are looking at a data table, the independent variable is going to be found on the left-hand side of that data table. The dependent variable depends on what's going on with the independent variable. So that will change based on the different changes in the independent variable. This is usually found on the right-hand side of a data table. So if we were to look at our data table here, we need to determine which variable is which. So if we take a moment, get straight in your mind which one you think is which. So as we look at this, we notice that on the left-hand side, we have temperature. That is going to be our independent variable. On the right-hand side, we have number of organisms. That is our dependent variable. As temperature changes, the amount of organisms, the number of organisms surviving or living in that area or whatever this is going to depend on that temperature. The next thing you need to know is what type of graph you're actually making. Most of the time for living environment, for biology, we're going to be making a line graph. However, you may also see a bar graph or a histogram. It is a very, very rare occasion where some other type of graph is required of you in this course, but there are many other types of graphs out there. Next thing, notice all of this in caps. It is crucial that each part of your graph has a consistent scale. You can't just write down random numbers. You can't just copy numbers directly from your data table. You have to calculate a consistent scale for each axis of your graph. So there's a simple way to find that. If you find the highest number in your data table, which is not always the last number, it could be in the middle, it could be in the beginning, then count the number of spaces on your graph paper. You will be able to calculate this. So the graph scale is equal to the highest data point divided by the number of spaces on the axis. Sometimes this is going to give us kind of an ugly number that we don't want to work with. But the nice part about it is if you round up, it'll give you a nicer number to work with. You can never round down, you always have to round up. So in our example here, we see that we have 60 as our highest number, and our number of organisms there is 59, so pretty close to each other, and those are our highest points. And then we have 20 boxes or 20 spaces on each side, on each axis of the graph. It happens to be a square this time, so it's kind of nice and easy for us. Now we can do our calculations. So for temperature, we take 60 divided by 20. That gives us 3. 3 is pretty easy to count with, but if you don't like it, you can always round up to 5 or 10. Those would be simple numbers. Then, for our number of organisms, our highest number is 59. We divide that by 20, we get 2.95. 2.95 is a fairly difficult number to count by, so we can always round that up to 3, 5, or 10. You want to avoid rounding it up to a number that's too high, because if you do, that crushes your data down and doesn't give you a very easy thing to visualize on your graph. So, as we have this, on the bottom axis there, the x-axis, I've counted by 10s, or excuse me, by 5s, skipping each one. And on the y-axis going up the side there, I've counted by 3s. As a reminder, and because you have to do it, you always have to include that your origin is 0, 0 if that's where you're starting. Okay, so put the zeros at that origin point. Now, we need to make sure that we label both of our axes correctly. Okay, so we need to put the correct axis label in the correct place. Your independent variable, the information that was on the left-hand side of your data table, always goes at the bottom, okay, the x-axis. Your dependent variable, the stuff that was on the information that was on the right side of your data table, is going to go on the y-axis, on the side. And it's important that we add a title for the graph as well. So, if we take a look, our graph will look like this. We still have our scale there. Temperature is labeled on the bottom, number of organisms on the side, and our title for the graph says the effective temperature on the number of organisms. Then, when we actually finally put the data on the graph, there are some specific things you need to do. First of all, you need to put a dot at each data point. Do not add any extra data points. If there is not a point given to you, you cannot add it. So do not put a point at the origin 0, 0 unless that is in your data. If it's not there, don't put it there. Then you need to connect all of your dots with a solid line. Make sure that you only connect the dots you have. If you extend beyond them, that is incorrect. We are only graphing the data that we have available to us. We don't know what's going to happen outside of the data we have. Then, because it's a good habit to get into, the Regents requires this, circle each data point. The reason we do this is because if you put a small dot and the line covers it, sometimes it's difficult to see where your data points actually are. Adding the circle emphasizes the location of that data point. So as we take a look, this is how we end up with our final graph. And that would be a graph that would receive full credit for being accurate and having everything labeled and plotted correctly. Now, quick review. Important things to remember when you're graphing your data. Make sure you label the origin 0, 0. Do not connect your data to the origin unless that is a data point. If you are using dates or years, you don't have to start with 0. Starting at year 0 is a little bit silly if you're graphing data from 1980 to 2015. Make sure you have a consistent scale on each axis. They don't have to be the same, but each axis has to be consistent. Label both your axes and connect your data points, but just connect your data points. Do not go beyond them. And that's how you can create a full credit graph.